Now you'll notice that I wrote on the notes quadratic formula for the ones that we need to do the quadratic formula on. Brandon, you ready? You sure? Okay. So most of these we're going to use that quadratic formula. Quadratic formula is sitting right there. And I'll tell you, if you're taking a test and you forget the quadratic formula, I will give it to you, okay? I don't want you to miss something because you thought it was over 2b instead of 2a or whatever. So I wrote that off to the side. Can you see that okay? Better. So this one, is this a quadratic formula one? Okay. So basically we just have to make sure that we're equal to 0 and we have an A, B, and C. How many of us remember this from last year? This goes all the way back to maybe 8th grade. Okay, so our A is what in this case? Okay, it's the number in front of the X. So it's a 1, okay? So when there isn't a number, it's a 1. Our B is, and our C is, okay? And it's important to point out that it works A, B, C as long as this is in the order of x squared, x, and then no x, which it was. So then we just use the formula. X equals negative 6. So what happens when we have a negative negative? Makes it into a positive 6 plus or minus square root of b squared. If it's a negative, you have to put it in parentheses. That's the biggest mistake people make. Minus 4ac all over 2a. I like to do what's called the discriminant first. Anyone know where the discriminant is? The discriminant is all this junk under the square root. So do me a favor and type this in the calculator. No square root, just the junk underneath there. So basically we get a positive 6 plus or minus square root of some number. 2 times 1 is 2. So what is that number you get? And everyone should try this because this is where people make mistakes. If you can't get the same answer as me, then you might not be able to get through this topic. I tried to wait, Miss H, but they told me to go ahead. And I was like, we can't start. And they were like, I got 28. Did you get 28? Please verify that you can do this getting 28. Okay? So we get 28. I cheat real quick. I forget how they want us to finalize this answer. Can I see that? Okay. Okay, so we get 28. So now we have to go off to the side and break down 28. So in some cases, they want us to give a decimal answer. If they want a decimal answer, we just type in square root of 28 and we move on. Okay, and we just work with this ugly decimal. But on this one, they want us to come up with a, we don't want a decimal answer. So I come off to the side and I'm going to write down 28. And I'm going to break this down to all of its factors. What can I divide 28 by? 7 and 4, and then 4 can be broken down to 2 and 2. So I'm going to pay attention to 7, 2, and 2. What is this number that's out right here that's blank? Anyone know? What'd you say? Okay, when we don't write a number here, that's really a little 2 right there. That means we're looking for the same number sets of 2. Do we have any sets? What is it? 2. So that means we take this here, and this is going to come out. One set of 2 comes out as a single 2. Okay? And this is what I call a leftover. So all that work I just did was to say that this means 6 plus or minus over 2. What do I rewrite square root of 28 as? 2 radical 7. So 2 came out because there was a set of that with 1 left over, which was that radical 7. The last step is if you can divide all 3 of the parts that are outside, meaning the 6, the 2, and the 2 on the bottom, by something, you have to. What number can I divide all those by? 2. So 6 divided by 2, 3. X equals 3. 2 divided by 2, I don't have to write the 1. It wouldn't be wrong to do that. And 2 divided by 2, I don't have to write 1 over 1. It wouldn't be wrong to do that. So there's my answer. If I was answering this on a test, I would say that's my answer, but Alex wants you to give both answers. So it's not going to accept this answer. So what are our 2 answers here? Okay, so 1 is the positive. I think I heard someone mumbling it. So that's one of the answers. And then the other answer is 3 minus the square root of 7. So this is the actual thing that Alex would want. Okay. If I change that into a decimal, Alex would say that that's wrong, meaning if I had typed in square root of 28 and hit enter, it would say that it's wrong. Any questions on that? So what's our next one? So our next one was what? Discriminant? Is that right? Okay. Go ahead and write this down. Negative 3x squared plus 8x minus 4. Anyone remember what the discriminant was? I just talked about it. It's a thing underneath the radical. Okay, so basically I can treat this as a quadratic formula problem. Okay, it's in order, so we got x squared, x, and then number. Okay, so my a is negative 3, my b is 8, and my c is negative 4. So I go to my quadratic formula, which says x equals negative b plus or minus b squared minus 4ac all over 2a. How many of you know that formula by heart? Let's get you too? Good. Maybe you knew it last year when you did it a million times. Forgot it. So the discriminant is just the number on the square root. So the last problem I said, let's go ahead and keep going. So x equals negative 8 plus or minus. I'm going to get a negative 6 down here. And I said, what number do we get when we do this? Again, if you can't do this, we're going to have some problems, so everyone should try this. It gets tricky when we have those negatives. So what number do we get when we do that? Yeah? 16. Were you able to get 16 out of that? So we get 16. Now we did all this work for that answer. And someone might beg, you might ask the question, well, can't I just focus on the discriminant and not write all that rest of the stuff? Yeah, but I just kind of wanted to show you where it comes from. So the question asks, what is the discriminant? So the first part, this part right here, the discriminant is going to be a blank on the bottom, is going to be 16. And then it's going to say how many real solutions the number of real solutions you get. And then it's going to say real solutions, something like this. And then we're going to give an answer there. So now we need to talk about what happens. How do we find out how many real solutions we have? On the problem we just did, we had 2 real solutions, okay? So it comes down to this. And this is kind of a note you need to put off to the side, is that if our discriminant is positive, which we are in this case, that means we can, weird things don't happen, okay? And on that last problem, how many answers did we get? 2. So if we have a positive discriminant, then we have 2 real answers, okay? Anyone want to guess the next situation? You're not positive, you're what? If you have a negative, okay? What do you think that means? Just guess. What do you think? Good. So if you're negative, then that means no real solutions, okay? So Mr. Hermits and Miss H and I sat down this morning, and one of them was really positive. I don't want to name names or point fingers. One was real negative. One had 2 solutions to the problem, and one was just had no solutions. Okay. And then finally, if you're not positive, you're not negative, you could be what? What's the other case? 0. Is that you? So you're doing good today, Miss H. Euler? Okay. So anyone want to guess what this is? Or remember from last year? This is 1 real solution. Okay. So that's a little note off to the side. So if I get 16, how many real solutions do I have? The answer is 2. If I had negative 16, I would have said no real solutions or 0 real solutions. If I got 0 under is my discriminant, I would have said 1 real. Okay. I didn't want to have to do 3 problems of this to show you those 3 cases, but that's what's going to happen. Is they're going to throw different cases at you. If I was doing this problem, I would write this down right here, this first part, okay, and then I would calculate the discriminant, and then from there you should just be able to move on, right? I got negative 52, no reals, and so forth. This one's kind of hopefully a quick one. I don't know if I've said this, but my hope is that once we've done these, we go find these topics and we knock them out, okay? Some of the topics that we've already done are still sitting there waiting for you guys to do. But anyways, okay. So we're now on solving word problem. Is that right? So that's the one I printed for you. It looks like this. Okay. So they say junk, junk, junk. A ball is thrown 5 meters. They don't, all this information right here doesn't matter in this problem. They're just telling you this information to say that this is why we have this equation. Okay. So when I read this, I don't even look at all that stuff. I just see there's an equation. The only thing that's important is that equation and this next thing. How long after the ball is thrown does it hit the ground? What is the height of something if it's on the ground? 0. If I say you're on the ground, the height is 0. So if I take this formula that says h equals 35 minus 5t minus 5t squared, and I say hit the ground, I'm basically saying when is it h equals 35 minus 5t minus 5t squared. Okay? And I don't know if you picked it up on the other quadratic formulas, we have to have it equal to 0. So if it said, when is it 20 feet off the ground, that would have been a 20 instead of 0, and we would have subtracted it. Okay? Did I do it right? Quadratic formula on this one? Yeah. So we're doing a quadratic formula here. Notice that it says round your answer. Okay, so they don't want square roots, they want some kind of decimal. So we're gonna when we get that discriminant, we're gonna square root it. They're trying to be kind of tricky here because they did what to the order of these numbers? They switched them around. Do we want to reorganize them, or can we figure out what A, B, and C is by looking at it still? Okay. You want to move them to the other side to put them in order? You wouldn't have to, but you can. A lot of times, personally, I like my squared value to be positive, but when you're using quadratic formula, it doesn't really it doesn't matter. But let's do that. So if I move everything to the other side, if it was positive, it's now negative, and if it was negative, it's now positive, and then I put them in order. Okay. If someone said, I'm not going to do that, and just started using the quadratic formula, they would get the same answers. Okay, so quadratic formula, here's my A, here's my B, here's my C. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So I still like, bless you, I still like to play the game of what's my discriminant before I square root it. I don't know if anyone noticed, but notice how I didn't put this 5 in parentheses and I did it on previous problems? Why didn't I put this in parentheses? Because it's not a negative. Negatives need to be in parentheses, okay? I got 725. Anyone confirm that? Bueller? So my discriminant was 725. So I got x equals negative 5 plus or minus square root of 725 all over 10. Now, if you're talking about this in real life and we're trying to figure out this throwing an object off a building, and you tell someone, oh, it's going to hit the ground at 5 plus or minus square root of 725, like, no, they want to know just one decimal, okay? So now we gotta figure this out. And we gotta come up with both answers. So what is the square root of 725? So this is where it gets kind of tricky. We want to keep that ugly decimal, all of its values. So we got something like 26.925 dot, 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 okay? So the two answers here, we want to do negative 5, and do you know how to bring that value down in your calculator? Yes or no? No. To highlight it. So push up on that answer. And if you, whatever you highlight in blue, if you hit enter on that, it brings it down. Okay? So we wanted to go ahead and clear what you just did. So just hit the clear button once. Okay? So we want to do negative 5 plus, and then go up to that and make it blue and hit enter. And then hit enter again. So now you should have done negative 5 plus that, and you got 21.925. Correct? And then you should do what to it? Whatever you have there, divide by 10. What did we get? you should get 2.192. It asks us to round to the nearest hundreds, tenths, hundredths, so 2 decimal places. So if the, give me 3 digits. So if we get 192, but they only want tenths, hundredths, 2 decimal places, then that means we look at this 9, we look at the next number and we ask ourselves, do we bump up that 9? Nope, we don't bump it up. We just throw this thing out. And our answer is this, 2.19. How many answers do we get here? 2. Okay, so if we're going to get 2 answers, let's find that other one. So now we got to use the calculator, -5 minus, go up and highlight that thing in blue. And then divide that by 10. And you get -3 point, what are the 3 digits? 192 again. And 192, again, we only want 2 digits, so we throw that 2 out. It doesn't bump up anything, and we get that. So you should be raising your hand now and going, wait, that doesn't make any sense. Why doesn't that answer make any sense? Okay. Well, this is time, right? So if I say, oh, you're going to hit the ground at -3.19 seconds, doesn't make sense, okay? So in real world applications, negatives don't make sense. There's a lot of questions in here, so we throw it out. There's a lot of questions that talk about the length of a board or the length of the side of a triangle. So if you went to the hardware store and said, hey, can you cut me a -5-foot piece of wood? They say, oh, the negative wood is all out of stock. Come back, never. Okay. So our answer is this right here, this 2.19. Any questions on that? Next one, solve an equation that is written. Where's my Alex? Oh, seriously. So here's a question while I'm bringing this up. Which one do you prefer better, quadratic formula or factoring? And what's the difference? There's our problem. Go ahead and get that down. X to the 4th minus 36x squared equals -35. So here's the thing about factoring. We're going to use factoring on this just to kind of refresh our brain on that a little bit, but you can always use the quadratic formula, but you can't always factor. So if you really like that quadratic formula, you could use it in this problem. What's the first thing that bugs you about this? Not in order, okay? How do we get it in order? Good. We need this to equal 0 on this side, so we're going to move that over. And hopefully at this point in our mathematical career, we kind of know that if something jumps across the equal sign, what happens to it? It switches signs. So it was a negative, so this one becomes positive. Good. What else bugs you about this? Should be something jumping out at you that's like, wow, that's weird. It's not squared. What's not squared? There's a squared on there. What's she talking about? Oh, there's an x to the fourth, right? So you can't use a quadratic formula on an x to the fourth. So what we're going to do in all of these problems, here's the trick. We're going to take this middle piece out, and I'm going to go over here to the side and say that x squared equals my blank. And when I'm done, I have to work with that. Okay? So what I'm going to do is I'm going to rewrite this problem the way I want it. I want this to be an x squared. I want this just to be an x. And I want this just to be 35. Okay? And I'm going to solve this down. And when I'm done, whatever my answer is goes in that blank. And then I got to solve that, and then I'm actually done. Okay? How many of you had Miss Fisher last year? Really? Nobody had Miss Fisher? Okay. So this is the way that Miss Klein and I taught you to factor. So we were going to make an x. We have 35 is on top, negative 36 is on the bottom. What two numbers times to 35 but add to negative 36? It's funny how these ones throw us off because you start to go 5 and 7, but it's 35 and 1 where they're both negative. So that adds up to negative 36. And then we went off and we made a box. And we said x squared, negative 35x, negative 1x, 35. Okay, so basically I rewrote this, and this is from here and here, and this is our new x values instead of this. We broke that up into those two parts. So then we get x, negative 35, negative 1. So this factors to x minus 35, x minus 1 equals 0. Am I going too fast? Okay. What are our two solutions then that come from this? Good. So we're asking what x value makes this equal to 0. So x equals 35. 35 minus 35 would give me 0, and then x equals 1. So if this wasn't a weird x to the fourth, I would be done. But it was. So then I have to take these two answers and I have to put them up here, and I have to find my final solution. Okay. So what I do is I'm going to start with 35. And I'm going to go ahead and make a second one of these. I'm going to give myself some room now. So actually, I'll just bring it down here. So I have x squared equaled blank, x squared equaled blank. So it was 35 and 1. How do I get rid of an x squared? So it's just an x. Square root both sides. So I square root both sides. And when you square root a number, what do? You have a positive and a negative value. So if I square root, and we got to write plus or minus here. So the answer is plus or minus the square root of 35 for this part. And for the other one, it's going to be the same thing, plus or minus. What is the square root of 1? Plus or minus 1. So this one actually ended up with how many answers? How many answers is that? 4. It actually has 4 answers. And if you remember, the fundamental theorem of algebra states that this power here tells you how many solutions you're going to end up with. So we had 4. So I think Alex would actually want us to write this as square root of 35, negative square root of 35, positive 1, negative 1, and give all 4 of those answers. Okay? We're going to write down one more of these, but not actually solve it out. But they can be very different, and I want to show you how it could be different. So do me a favor and write this one down. I'll make it a little bit larger here. And make sure and keep it under the same problem type. So if I was doing this problem, I would rewrite this like this. I would say, I want it's always this middle thing, whatever that middle is, I'm going to go off to the side and say, really, this is what it is. And actually, in hindsight, we're going to have how many answers here in the first part? How many answers did we have in the first part? Thank you, Miss H. It's like it's Monday or something. So I know I'm going to end up with 2 answers, but this chunk I go off to the side and I say x minus 3 is going to equal whatever I end up with. So if I was doing this, I would rewrite this problem as x squared, so you just kind of get rid of that, minus 5x, kind of get rid of that, plus 4. I would solve this out, and when I'm done, whatever my answer was, I'm going to say x minus 3 equaled whatever that is. X minus 3 equals whatever this other one is. Right? And I would give myself plenty of space to do all that work. And no, I got to go back to it. So for this problem, they tell me I get the answer from this first part, and it says that it's 1 and 4. Okay? So I cheat a little bit. But if I get 1 and 4, so I do all this work, dot, 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 and I get x equals 1, x equals 4, then what do I have to do with those? I got to put it in that thing. That's why I wrote them down here. This is for this one, and this is for the other one. So then I got to solve that. X minus 3 equals 1. So really x for this case is what? So really my answer is 4 and 7. Okay? So whatever's in this middle here, I'm going to go off to the side, or I can write it twice down here, and I can do that. Okay? It's called substitution. So we had that ugly thing, and we're going to just take it out. We're going to substitute. It's kind of like when Mr. McConnell's out, you get to substitute the ugly Mr. McConnell, and in comes a nice-looking, who was the sub on Friday? Huh? Mr. Keegan. My dad comes in. We got one more? Is that right? Last one? Okay. Let's go ahead and write that down, and then we'll start it here in about 5 seconds. Okay, this is the same problem we just did. It's just problem type 2. So they made it a little bit more complicated or made it different. Where did I say we draw our attention to? Which is the thing that we take off to the side? the middle, okay? So basically, I take this middle thing here, and I go off to the side, and I say x to the 1/3 equals blank. And every single time this works out, that if I get rid of that x to the 1/3 and call that blank, then I can rewrite this problem as 3x squared plus 1x, there wasn't a number, minus 2 equals 0. And when I'm done, I got to go back and mess with that x to the 1/3. So we're going to factor this thing. So this is an x box. The top here is the first and last thing multiplied together. The bottom is the middle number, which is a 1. What two numbers times give me -6, but add to give me 1. 3 and 2, where 3 is positive and 2 is negative. So now I draw my box. 3x squared, 3x, negative 2x, negative 2. You could have used the quadratic formula on this. How many of you would say, man, why aren't we just doing that? Anybody? So I get 3x, x through 1, and negative 2. So then after all that, I have 3x minus 2 and x plus 1 equals 0. So what are my two solutions I get from this? Brandon? What are my two solutions I get from this? What's one of them? X minus 1. X equals negative 1 from here. This one's a little trickier. Some people can do it in their heads. When I do it in my head, sometimes I mess up. But we're asking, when does this thing equal 0? So I can just do that. I can just say, when does this equal 0? I can set it equal to 0 and solve it. So I'm going to add 2. And then divide by 3. So I can say x equals 2/3. Okay? And I should circle these very lightly because those are not the answers. Because now I got to put it in the sub machine. Okay, so I take those two answers and I say, well, what if I said, just kidding, it's x to the 3rd. I'm going to go off to the side here. X to the 3rd equals 2/3. And x to the 3rd equals negative 1. How do you get rid of a 1/3? Where is that 1/3? Where is that? What's that thing called up top there? It's an exponent. So if we have an exponent of 1/3, we're going to get rid of a 1/3 by timesing it by 3. Okay? Or raising it to the 3rd. So what we basically do here is I put this in parentheses and raise it to the 3rd. That's how you get rid of a 1/3. So in your calculator, type this in, parentheses 2 divided by 3, parentheses raised to the 3rd. Do you want to do that in your head? Did it give you an ugly decimal? Hit the math button and change it into a fraction. You know how to do that? 8/27. Okay, and then we got to do the same thing to the negative 1. So I'm going to raise this to the 3rd, raise this to the 3rd. Negative 1 to the 3rd, anyone do that in their head? Negative 1. Okay. So as much as these are close to the answer, these are the actual answers. Got to put it back in the machine. I'm not going to do one more, but I just want to talk about it real quick, and then we'll be done. I just want to talk about what the setup would be for the next one. Oh, that's the same. Are they all like this? Okay. So look how weird this one is. Okay, so it's the middle thing is x to the -1. So I go off to the side and I just write x to the -1 is going to equal whatever we're dealing with. Okay, and then I rewrite this as x squared plus x minus 30 equals 0. I get my answers. And then I got to plug it into this. Anyone know how to get rid of a -1 in the exponent? So to get rid of a -1 in the exponent, we're going to raise it to a -1 because -1 and a -1 is what? So when we're finished here, we're going to raise this to a -1. And the other side. Okay. So that's how those get ugly. There are 5 homework problems just like normal. Mark's going to say go.